Hello and welcome to day 1 of the challenge series. In first few challenges, we'll start with the basic challenges to get familiar with the database tables. So let us see our first day problems. So let us first understand the business context. The business context is that the owner wants to celebrate the anniversary of his company by throwing a party to pay gratitude to his customers. But he only wants to invite only those customers who are active. So technically, we need to list all customers who are active. Now, let us look at the approach to solve this question. So, first, we will identify the correct table. In our case, it is the customers table. Then, we will filter for records where active is equal to 1 so that we get the active customers only. And then we will select only those columns which are required. So, we'll use the first name, the last name, and the email so that the invitation can be sent to the email. Okay, so now let us look this into practice. All right, so let us start with our customer table. So we select all the columns from our customer table and let us look at the table columns first. So we have customer ID, we have store ID, and then we have their first name, last name, email. And if you see there is an active column, so this the data type of this column is bit, and so we have 1 and 0 as the flag. 1 indicates that the customers are active and 0 indicates that the customer is inactive. And if you see there are 599 rows in total, so we have a table of customer that has 599 records. Let us now filter this record where active is equal to 1, and let us first see how many records we get. So if you see, we have 584 rows, which means 15 customers are inactive and 584 customers are active. So this is the records that we want, but we do not want all the columns. We only select meaningful fields. So let us take only the meaningful field, that is first name, last name, and email, so that the invitation sent can be sent on their email. So this is our result that we want. But as in standard practice, giving a separate first name and last name is not a good practice. So we'll use a method of SQL, which is concat method, and this will combine the two columns with the same data type, that is the first name and last name, which is the string data type. And we now give an alias to this new column as customer underscore name. So alias is a reference name given to a column for referencing. And now let us execute this. So this is our final table that is required by the customer. So we can export now this result, and this is our solution. Okay, so at the end of each problem, I will provide at least one tip that would assist you in becoming a better SQL developer. So here are today's tip. Always check ERD for the right table or column before writing a query. This would help you strategize your approach and save time if you know which tables to look for and which attributes to look for. Second, use clear column aliases for readability and clarity. This also significantly reduces the typing required, especially in complex queries. Third, apply filters early to reduce result set size. This improves the performance and efficiency of your query. Okay, so now let us look at the second problem. Let us first see the business context. The owner wants to increase the profitability by renting premium films which cost greater than $2.99. So we will have to write a query to get list of all films greater than $2.99. So the approach to solve this problem is similar to the first problem. So first we identify the correct table. In this case, it is the film table that holds the rental rate. Then we will apply a filter where the rental rate is greater than $2.99, and then we'll select the relevant columns. So let us look this in practice. Okay, so now let us explore the film table first. We select all the columns from film table and let us see the columns. So we see it has 1000 rows. That means it has 1000 records, and we have film ID, title, the description, release year, rental rate, length, replacement cost, and so on. So now what we want is the films whose rental rate is greater than $2.99. So we apply the filter where rental underscore rate is greater than, we use the greater than operator, and then we apply and then execute it. So now if you see there are 336 rows, this means that there are 336 films which are greater than or whose rental rate is greater than $2.99 or $2.99. Let us only now select films or columns that are required. So we only select the title. Let us also select the film ID and the title, and let us also select the rental rate. So now if you see, here is the list of films which are greater than or which whose rental rate is greater than $2.99. So the greater sign indicates that all the films will be having the rental rate greater than $2.99. If you want to include the films which are at $2.99, we can use an equal to operator also. So greater than and equal to operator. And now if you execute this, so it also includes the films which whose rental rate is $2.99. And if you see, there are 659 rows. Okay, so let us now look at the developer's tip. So first, always use correct data type when comparing numeric values. Correct data types tell SQL engine how to interpret and use the values stored in your dataset. Second, return only required columns to keep queries fast and output focused. This increases the efficiency of the result from your query. So that is for today's problem.